Welcome back to my channel. Today I am going to discuss about Born-Haber cycle. So the Born-Haber cycle is one of the thermodynamic cyclic process. So it is used to determine the lattice energy. We know that the direct experimental determination of lattice energy is not so easy. So there are determined with the help of a that is indirect method, Born-Haber cycle. So let us know what is the lattice energy. The amount of energy released when 1 mole of ionic solid formed from its free isolated gaseous ions brought from infinite distance to their respective equilibrium sites is called a lattice energy of that solid. In a simple way we can define as here some amount of energy is released to form ionic solid crystal, that is a lattice a solid crystal. How it is formed? By the two ions. So here some amount of energy will be released, that is called the lattice energy. So here we can easily calculate with the help of a Born-Haber cycle. So the Born-Haber cycle involves 5 steps. So here we have some conversions. So we can observe here the Born-Haber cycle can be explained by taking the example of NaCl crystal. So here it involves the 5 steps. Okay, the first step is conversion of metallic sodium into gaseous sodium atom. Okay, here we can observe this is a metallic sodium atom. First we have to convert the metallic sodium atom into a gaseous sodium atom. So here which requires some amount of energy. So here for the conversion of a metallic sodium atom into a gaseous sodium atom which requires some amount of energy, that energy is called sublimation energy. So how much energy it is? 108.5 kilojoule per mole here. So the conversion of metallic sodium into gaseous sodium atom. So this metallic sodium will be converted into gaseous sodium atom which requires some amount of energy. So that energy is called sublimation energy. So it is denoted by S. Okay, this is the first step. The second step is dissociation of gaseous chlorine molecule into gaseous chlorine atom. So here we can observe we have a chlorine molecule. So we have to convert this gaseous chlorine molecule into a chlorine gaseous atom. So this dissociation requires some amount of energy. So that is called a dissociation energy, that is 243 kilojoule per mole. So this is the second step, that is dissociation of how you can define the amount of energy is required to convert a gaseous chlorine molecule into a gaseous chlorine atom. So that energy is called dissociation energy. So you can see here this is the gaseous chlorine molecule. It is converting into a gaseous chlorine atom which requires a dissociation energy, that is denoted by a D. So that is 243 kilojoule per mole. Okay, then third step. So third step is conversion of gaseous sodium atom into a sodium ion. So here in the first step we are converting metallic sodium atom into a gaseous sodium atom. Now we have to convert a gaseous sodium atom into ion. So which requires some amount of energy. So here the conversion of the amount of energy is required to convert a gaseous sodium atom into gaseous sodium ion. So that energy is called ionization energy. So 495.2 kilojoule per mole. So then fourth step, the conversion of gaseous chlorine atom into a chloride ion. So here we are not requiring a energy. Here the amount of energy is released. So the amount of energy is released when a gaseous chlorine atom is converted into chloride ion. That energy is called electron affinity. So always when amount of energy is required, that is denoted by the plus sign. When the amount of energy is released, it is denoted by a negative sign. So in the fourth step, the conversion of a gaseous chlorine atom into a chloride ion. This is the fourth step. So conversion of gaseous chlorine atoms into a chloride ion. Here this gaseous chlorine atom will be converting into a chloride ion. Here some amount of energy will be released, that is minus 342.3 kilojoule per mole. So in the fifth step, the combination of gaseous ions to form a solid crystal. So here we know that the lattice energy definition. Here some amount of energy will be released when the two gaseous ions are combined to a infinity. So there is a formation of a NaCl crystal. So this is what here, with the help of a Born-Haber cycle, we can calculate the lattice energy. Yes, this is what Born-Haber cycle. It involves the 5 steps. The first step is conversion of a metallic sodium atom into gaseous sodium atom. So which requires the energy, that is called a sublimation energy. In the second step, the conversion of gaseous chlorine molecule into a gaseous chlorine atom, which requires some amount of energy, that is called a dissociation energy. So in the third step, the conversion of sodium gaseous atom into a sodium ion, so which requires some amount of energy, that is called ionization energy. So in the fourth step, the conversion of gaseous chlorine atom into chloride ion. So here which releases amount of energy, that is a electron affinity. Now the combination of a cation and anion which brought together, so there is some amount of energy will be released here. Okay, that energy is nothing but the lattice energy. It is denoted by U, that is minus 758.7 kilojoule per mole, which form the NaCl structure. Okay, that is the NaCl crystal lattice. Hope you understand Born-Haber cycle. Thank you.